Hello everyone and welcome to the Sky This Month for April 2023. My name's Paul Martinaitis and this show is brought to you by the Astronomical Society of South Australia. So now that we're moving into autumn and we've just come off of daylight saving here in Adelaide, means the nights are getting a bit longer and we can start our observations a lot earlier now. So hopefully we'll get some nice clear nights so we can enjoy some of the beautiful sights that the autumn sky has to offer. And one of the big things, of course, occurring this month is the solar eclipse here in Australia on the 20th of April. So we'll talk a little bit more about that in the show as well. So without further ado, let's take a look at the autumn sky for April. So we'll begin our survey in the sky in the west. So these are the constellations that we'll set first in the evening. So we're looking at about mid-month, the 15th of April, and the time is around 9 p.m. So roughly 2 hours after, 1.5, 2 hours after it gets truly dark. So we can see, of course, summer's now well behind us. So the great summer constellation of Orion is pretty much starts the evening, even this early on the horizon. So time to let it go and wait until much later in the year to get a good view of Orion again. And the same pretty much goes for Eridanus. Half of that extremely long constellation is also below the horizon at the beginning of the evening. Looking a bit further up though, Canis Major is still reasonably well situated for observation. So you may recall in the last show, the February show, we talked about observing Sirius. So you might want to give that another go early in the evening when it's still a reasonable amount of elevation, if the seeing is good, and see whether you can get a glimpse of Sirius's white dwarf companion, Sirius B, sometimes called the Pup. And of course, there's also a lot of other fine open clusters in Canis Major as well as Four's Helmet, which we've looked at before. So looking a little bit further up still, the constellations that form the great ship Argo Navis, Puppis, Carina, Vela, and Pyxis, they're very, very well placed now. This is probably one of the best times of year to observe it, nice and high up in the sky. And in particular, this month, so last month I talked about a few of the open clusters that you can observe in Puppis. This month, I'm going to concentrate on Vela, the sails, and there's some wonderful objects in Vela. So I'm going to share just a few of those with you later on. And also, of course, don't forget the Eta Carini Nebula there in Carina. Wonderful sight in any sort of instrument, from binoculars right through to telescopes. So looking north now, towards the northern sky. So those of you who have viewed a couple of my shows would know that galaxies are my very favorite objects. And we're entering galaxy season. You can see that by all the little red dots on the screen. So as we head well into April and into May, that's well and truly what I call galaxy season, because we have all of these galaxies around Coma Berenices, Virgo, and also Leo. So I'll just remind you, Leo is a great constellation. It's a little bit like Scorpius and Orion, and a few others. It actually looks sort of what it represents. So you can see there's the head of the lion, the body of the lion, and then that triangle forms his tail. So it's very distinct in the sky. So it makes it easy to find objects in and around a constellation like that. So there's a number of fine galaxies in Leo, but probably some of the best ones are the so-called Leo triplets. So I'll just put my Telrad circle. So I think we've talked about them before, but I'll just remind you where they are. So the main galaxies in that trio are M65 and M66. So if you just look for that triangle of stars there, I'll just zoom out a bit. And if you place your Telrad about there, or you can star hop from Theta there, and then you'll come to M65 and M66. And the great thing about those galaxies is you can generally, if you've got a wide field eyepiece, you can generally fit all three of those galaxies in that trio in the same field of view. So you won't see this sort of detail, of course, but you will see the cores. You'll see the halos, and you can certainly make out the different shapes. So you'll be able to tell that M66 is relatively round, M65 is slimmer, and then you'll see kind of a streak almost at right angles to the other two, which is this galaxy here. So as we move over towards the east, we can see that Virgo is now becoming quite prominent early in the evening, and as, of course, autumn progresses, that will rise higher and higher in the sky, along with all those fantastic galaxies in that region of the sky. Looking towards the horizon, we can see Scorpius is now starting to make an appearance. And again, as April goes into May, that'll start to rise higher in the sky as well. Looking straight above, we can see there's Hydra snaking its way across the sky, the longest constellation. So there's a number of fine objects in Hydra, of course. I've mentioned them before, but I can't resist mentioning just two of them. The first is this planetary here, the Ghost of Jupiter, also called NGC 3242. That's, as you can see, very, very well placed for observation at the moment. So, being a planetary nebula, the trick there is to crank up the magnification. So I'll just crank up the magnification in this simulated view. So we're looking now at about 190 times. I might just bump it up a little bit more. And you can see there that on a good night, through a telescope, what you'll see is that sort of eye pattern. So you'll see a sort of a roundish pale disk. Sometimes you might see a little bit of colour. I usually see it as a fairly pale sort of greyish colour. And then in the middle, you'll see this eye-like structure with a dot in the middle, which is the central star of the nebula. So planetary nebula in particular, because they have such a high surface brightness, really can bear high magnification to bring out those details. And they also respond very strongly to any sort of nebula filter, but in particular an O3. And the other object, I'll just swing us back so the horizon's down the bottom. The other one that I can't resist mentioning at this stage, of course, is M83, one of the greatest galaxies in the southern sky. It's really one of those great grand design face-on spirals, and you can find that pretty much. I'll just put the Telrad circle on so that you can see. I'll just place that there for you, and you can see that it's pretty much halfway along that line between Theta Centaurus and Gamma Hydrae, right there. And that is a really fine galaxy. I'll just decrease the magnification a bit to make it a bit more realistic. So, of course, through a telescope, you won't see those colours and the stars, unfortunately, but on a good night, through a 10 or a 12 inch, you will see quite a bit of that, well, at least a hint of that spiral structure. So you'll see the outer shape of that halo, and you can sort of get hints of this great swirling pattern. Again, don't be frightened to bump up the magnification to try and bring some of that detail out. So finally, looking towards the south of the sky, like we saw before, you can see right above, there's the constellations of Argo Navis, very, very well placed for observation at the moment, probably the best positioning of the entire year. And in particular, Vela, the sails. We'll talk a little bit more about some of the fine objects a little bit later. Looking a little bit further down, Centaurus and Crux are also nicely placed, as well as constellations such as Dorado. There's a lot of fine galaxies in Dorado, and the large and small Magellanic Clouds. So let's now look at the lunar calendar for April. So now that daylight saving's over, of course in Adelaide at least, our clocks have been wound back by an hour, and that combined with the fact that the sun is setting earlier now that we're heading towards winter means that we can begin our observations a lot earlier. So on the 1st of April, true darkness began at 1935 and went through to 5:04 in the morning. By the end of April, darkness begins at 1900 and will go through to 5:24 in the morning. So that's a really nice change from summer where, we had to often wait 9:30, 10 o'clock or even later before it really truly got dark. So the period of the month where the moon won't interfere, where we'll get nice dark skies for deep sky objects, will begin on around the 14th and go through till the 23rd. So the moon phases are full moon will be on the 6th, last quarter on the 13th, new moon on the 20th, and first quarter will be on the 28th. So, of course, this month, the really big event that everyone will be talking about is the total solar eclipse, which will occur on the 20th of April. So, unfortunately, the path of totality, you can see there, just really licks mainland Australia, just on that peninsula there coming off of Western Australia, near the town of Exmouth. So that's really the only place in Australia where you'll actually be able to see the total eclipse. For the rest of Australia, it'll just be partial. So quite a few viewers of this video, I imagine, would have already made plans to go and see the total eclipse in Exmouth. So if that's the case, I really wish you safe travels, and I also hope you get great weather, nice and clear, so you get a good view of the eclipse. So for the rest of us, the eclipse will be partial. So I've got here the times for Adelaide. So in Adelaide, the maximum eclipse will only be about 21%. So in other words, only 21% of the sun's disk will be covered, but still might be worth observing if you have appropriate equipment. In other parts of Australia, the times and the degree of obscuration will vary. So, for example, in Broome, I think about 89% of the sun's disk will be covered, and in Perth it's about 70%. So the degree to which the moon will cover the sun's surface does vary a lot, depending on where you're viewing. But in Adelaide, on the 20th, these are the times where the eclipse will occur for us, the partial eclipse. So it'll begin, so this is in Adelaide time, or ACST, Adelaide Central Standard Time. So the eclipse will begin at 12:30 when the moon just begins to touch the sun's surface. Maximum eclipse will occur at 13:30. So that's when 21% of the sun's disk will be covered. So at that point, the general sky will appear to be a little bit darker due to that covering, and also if you have the means, which we'll talk about next, to safely view the eclipse, you'll actually see the shadow of the moon move across the sun's disk. By 2 o'clock, the moon will have started to retreat from the sun's surface, and by 14:30 or 14:35, the eclipse will have ended for us here in Adelaide. So I just wanted to say a few words about safely viewing a partial eclipse. So with the total eclipse, it is safe, of course, to view the eclipse once totality is in progress, where the sun completely covers the sun's disk. For a partial eclipse, there is no time at all where it can be viewed with the naked eye, because otherwise permanent eye damage will occur within seconds. So to view a partial eclipse, appropriate filtration has to be used at all times. And there's various filters that can be used. But if you don't have a dedicated solar scope or a scope with a properly designed and fitted solar filter, I think the best way and the safest way to observe the eclipse is to use one of these solar safety glasses. So I've shown there the Beta solar glasses. They're probably the best known brand. They seem to be quite widely available in Australia, and they only cost about $5 each. So you might want to consider ordering a pair. They still seem to be available at the moment, but of course, as we get closer to the eclipse, those stocks will probably dry up. So if you want to get a pair, I would try and order them soon. So these glasses consist of a film, a mylar film, and they're quite safe to look at the sun with. The only thing you must remember, they cannot be used with any optical aids. So they're not to be used in conjunction with binoculars or a telescope. They're only simply for looking at the sun with the naked eye. And if you do that during that partial eclipse, you'll be able to see the disk of the moon move across the surface of the sun. And the other thing I should add is if you do purchase these beta solar glasses, I recommend that you order them from a reputable source such as Bintel or some of the other astronomy retailing websites, because that way you can be guaranteed of getting a genuine product. If you order them off of Amazon or eBay, Gumtree or some website like that, unfortunately, in the past there has been some people scamming and selling counterfeit products. So my strong recommendation is to buy them from a reputable retailer to ensure that you're getting the authentic product. And then you should have a perfectly safe eclipse viewing experience. So let's now take a look at the solar system. So as we head into April, not really a good time for observing most of the planets due to various reasons. So let's start off with the inner planets. So we can see that Mercury begins the month just emerging from behind the sun. And as we progress through April, it moves a little bit further away, but it never really moves far away from the sun. So really not a good apparition for Mercury this time around. Venus, on the other hand, is pretty well placed in the evening sky, certainly for the first half of April. And the same goes for Mars as well. Again, visible in the early evening sky. The only thing about Mars is, of course, the distance. So I'll just wind back so we can picture what's happened. So I think opposition was around the 18th of December. That's when the distance between us and Mars was very close, well, as close as it gets for this time around. And the disk of Mars was about 18 arc seconds or so. So now that we've sort of moved into April, we can see there that relative distance has increased considerably. So although Mars appears still relatively bright, the apparent diameter has decreased to 6 arc seconds. So that makes it very, very difficult to pick up surface features. So as far as visual observation goes, at least I think the window for Mars is over, and we'll have to wait another 2 years for the next opposition. So looking now a little bit further out to Jupiter, we can see Jupiter is pretty much almost in conjunction with the Sun, and therefore unobservable. And if we just rotate a little bit around, we can see Uranus is in a very similar position. It's very, very close to the Sun. Technically, it might be observable in the very early evening, but really it's getting too close to the Sun for good observation. So the only two planets we are left with are Saturn and Neptune. So they will be appearing in the early dawn sky. So Saturn and Neptune, both quite well placed for observation, but you'll have to get up nice and early from, say, between 4 a.m. and sunrise would be a good time to view them. So like we saw, really the only two planets really worth observing at the moment are, besides Venus, perhaps in the early evening sky, Saturn and Neptune. So I've shown here what the sky will look like on the 16th of April at around 5:30 a.m. if you happen to be up at that time. So you can see there we have Saturn fairly high up in Aquarius, and that will actually be joined on the 16th by a nice slender crescent moon, which will make quite a nice sight. Actually, close up there, so you'll be able to see the crescent moon there. And certainly, if you happen to have your telescope out of any size, be sure to take a look at Saturn. It's pretty high up in the sky at this point, and it's already, even though we're far from opposition, its apparent diameter is still fairly large, and you'll get a nice view, hopefully, of the planet's disks, the rings, and also, of course, its associated moons as well. So the other planet, like I said, was Neptune. So Neptune is also reasonably well placed for observation, and you can see there that it's in that region there near the tail of Pisces, which is kind of poking above the horizon. And if you haven't seen Neptune before, this is a good opportunity to find it because it's actually near a relatively bright star at the moment. So I'm just going to zoom in on this area of the sky here. And again, this will be the situation pretty much for the entire month of April, but it will be in the pre-dawn sky between, let's say, 5 to 6 a.m. So I'm just going to zoom in there to show you a closer look. So there's the tail of Pisces. And the reason Neptune will be relatively easy to find is because if you take a look at those red arrows there, there's a star called 20 Pisces. And it's about a 5.45 magnitude star, so you can see it with the naked eye under a dark sky, or otherwise you'll certainly see it through your binoculars from a city sky. And 20 Pisces kind of forms a chain of 3 stars, equally spaced stars, relatively bright, around magnitude 4 to 5, and they're equally spaced. So all you need to do is find that chain of 3 stars near the tail of Pisces, and you might wish to star hop from Gamma Pisces, which I've indicated there with the red arrow to the left, and Neptune will always be within half a degree of 20 Pisces for the entire month of April. So makes it easy. If you find that star, you'll know that Neptune will be in the same field of view, certainly of binoculars or a wide field eyepiece in your telescope. So it's a really good opportunity to find Neptune if you haven't seen it before, or if it's been a while since you last looked at it. So here's a simulated view of Neptune through a 12-inch telescope at 115 times. So the actual field of view of this particular combination is 0.9 degrees. So you can see there, centered on the star 20 Pisces, Neptune's well within that field of view. And it would also be, of course, well within the field of view of a pair of binoculars. So really easy way, and it will remain so for the rest of April. So a really easy way of locating Neptune at the moment. So in the February show, we looked at some objects in Canis Major and the nearby constellation of Puppis. And this month, we're going to concentrate on Vela, which is just sort of next door to those 2 constellations. So Vela, of course, is part of what used to be called long ago Argo Navis, the sort of the great ship in the sky from Jason and the Argonauts. So you can see there, Puppis makes the front of the ship or the poop deck. You've got Carina, the keel, Vela, the sail, and Pyxis, the compass. So Vela can be a little bit hard to find. The stars are only moderately bright, most of them, so they're a little bit hard to see under a suburban sky, although under a dark sky, they're fairly prominent. So I find the best way to find Vela when the sky's less than optimal is to firstly identify the false cross. So I'll just zoom in a little bit. I'll get rid of the lines. So over to the left here, of course, we have the real cross, the Southern Cross, crux. And then over here is what's sometimes called the false cross. So it's sort of like a larger imitation of the Southern Cross. So the thing to remember is when you're looking at the Southern Cross, the false cross, the lower part of the false cross is part of Carina, and the upper part is part of Vela. So I use that then as my starting point to identify the stars. So I'll put the lines back. So you can see Carina, or the keel, starts at the Canopus, the second brightest star in the sky, comes across the bottom of the false cross, and then it loops around the Eta Carini Nebula in this direction. If we now start at this top section of the false cross, that's Vela, and it loops around to a point to Gamma Velorum, which is about a 1.6 magnitude star, 1.5, 1.6, fairly bright, you can't miss it, up through lambda, and it makes that loop like so, back to the false cross. So I find that a very easy way to locate Vela. The bottom part of the false cross is part of Carina. That upper part of the false cross is the bottom of the loop that forms the sail, or Vela. So once you've identified Vela, our first target that we're going to look at for tonight is actually Gamma Velorum itself, which is a very nice multiple star system. So right there at the tip of Vela. So this shows you a simulated view through an 8-inch scope at 92 times, but it really should be split. Well, the two main components, at least A and B, should be splittable in binoculars, and the other two components, C and D, should also be a fairly easy split, really in any sort of instrument. So it's really a nice, very nice looking quadruple system. And the unique thing about it is you've got the A and B components in that direction, and then the much fainter C and D components sort of come off at a right angle. So it makes a very distinctive pattern in the eyepiece. And the other thing interesting to note about this multiple star system is that A and B are themselves spectroscopic doubles. So what that means is we can't split them optically, or in other words, we can't see it through the eyepiece, but we can tell from the spectra of those stars that there's actually two stars in close orbit to one another. So this brighter one here, this A component, consists of two stars, and the B component also consists of two stars, and they're in orbit of one among sort of about one another, and A and B are in turn in orbit around a common center of gravity as well. The C and D components probably are not in orbit directly in this system, but they do belong to the same general association of stars. In other words, they were probably born in the same cluster, born at roughly the same time, roughly 5 million years ago, and they're all moving in the same direction in terms of their proper motion. So looking at the A component, just a few details about the stars. So one of them is an O-type star, about 29 times the mass of the Sun, and has a surface temperature of 35,000 Kelvin. So a very, very hot star, as all O-type stars are, and also extremely massive. Its companion, which remember we can only see via the spectroscopy, is what's known as a Wolf-Rayet star. So that's only 9 solar masses, because it started off much larger, probably around 30 solar masses, but it's managed to eject a lot of that mass. So that second Wolf-Rayet component is a star that's really towards the end of its life, and it's predicted to go supernova at some point in the relatively near future. And the other point of note about that Wolf-Rayet star is, like all Wolf-Rayet stars, are extremely hot. So this one actually has a surface temperature of 57,000 Kelvin. So just a few things to ponder while you look at this wonderful star system through your eyepiece. So the next object I'd like to look at in Vela, this is one I think many of you would be familiar with, is NGC 3132, also known as the 8-burst nebula. So it's a planetary nebula, another planetary nebula. We see quite a few of those. And it's probably my favorite. The reason being it's the first planetary nebula that I saw when I first got my 12-inch telescope. Through the 12-inch at 115, generally it looks grey, so I can't see any colour in it, but it looks like a small grey donut, but not perfectly round. It has certainly a distorted shape, like you can see in the photo. And the interior of that donut appears fairly solid, so you can see there in the photo and that's the reason for that, is that interior section has quite a high surface brightness as well. It's not very dark compared to the sky background. And the central star key thing about this is unlike something like, for example, the Ring Nebula, the central star in this nebula is relatively bright at magnitude 10. So readily visible even with that bright background. Sometimes you may need averted vision to see it, but often you can see it with direct vision. So our final object in Vela is known as the Vela supernova remnant. So a lot of you would be familiar with the Veil Nebula, which is a very famous supernova remnant in the more northern part of the sky, which we can still see fairly well at the right time of year. So this is, if you like, a version that we've got here in the Southern Hemisphere. A little bit fainter than the Veil Nebula, more spread out, but it shows a lot of the same filamentary detail. It's a really wonderful object, one of my favourites, and perhaps a bit of a neglected object. A lot of people have photographed it, but it's perhaps not one that's been seen visually as much, but it's really worth hunting down. So this is a slight challenge object in the sense that you definitely need a dark sky. City skies will totally obliterate it. So one to say for Stockport on or similar dark site on a nice moonless night. And you also need, I think, to use an O3 filter. It's pretty much essential. I find even in the 12-inch scope, without the O3 filter, it is visible, but it's extremely faint. Put the O3 filter in and it just lights it up. It's like looking at a completely different object. So I think the filter is perhaps more important than for this object than having an extremely large aperture. I think you would still get a reasonable view in maybe any telescope above a 6-inch, provided that you use a filter. So this is a remnant of a star that exploded between 10 and 11,000 years ago. And in recent decades, they've actually found the pulsar, which was left behind from that explosion. So it's known as the Vela pulsar. Now, visually, it's quite dim at magnitude 26, so obviously not going to be visible in any sort of amateur telescope. But in radio and X-ray and gamma wavelengths, it's one of the brightest pulsars known. So I'll just sort of show you how to locate it. So we'll go back to Stellarium. So that's where we were looking at the 8 burst. So we're just going to move back down, and our starting point is going to be E Valorium. So there's Gamma Valorium, that multiple star that we started with. And then you've got Lambda Valorium here. And you can see that E Valorium kind of forms a triangle with Lambda and Gamma. So that's your starting point, and I think that's about a magnitude 4 star, so relatively bright, shouldn't be too hard to find. So once you find that and you've located it, you'll find the brightest parts of the remnant around E Valorium. So because it exploded 10,000 years ago, it's spread over a huge angular area across the sky because it simply had 10,000 years to expand. Compare that to, say, for example, the Crab Nebula, which is another supernova remnant that we can observe quite readily. That's quite a small object for us to look at because it exploded roughly 1,000 years ago. So it's had, a tenth of the time to expand. So the brightest parts you'll find around E Valorium. So the best thing is start at E Valorium, put your O3 filter in, and just start moving the scope around and exploring the filaments. So some of the brightest parts will be there. And then what we want to do is we want to sort of go in an arc. So we want to follow the filaments down, and they'll sort of, you'll sort of know where they are, but then they might be gaps between them. Follow the filaments around, and you should be able to follow them kind of all the way around to around these 2 stars here, B and N Valorium. And then you can follow, there'll be a few filaments on your way back to E Valorium. So the idea is start at E, move around here a bit, and then just slowly loop, following the filament trail, if you like, up to B Valorium, and then loop back to E. So that's the main part of the, probably the brightest part of that part of the supernova remnant. And there's also another part that's probably even brighter, and probably the easiest part of the nebula to see, and that's all the way over here, and that's called NGC 2736. bright enough to get its own NGC number, sometimes also known as the Pencil Nebula or Herschel's Ray. So there's sort of a zoomed in picture of it. And through the eyepiece, of course, you won't see it in colour. You won't see all of these filaments that you see here above taken through a very large telescope, but you will see this main filament quite bright, provided again that you use that O3 filter. You'll see this division like a tail at the bottom, and you'll see some of this mottling in between as well. So if you imagine this part of the photo in grey and considerably dimmer, that will give you a good impression of what you can see in the eyepiece. So it's really quite an amazing object to look at, particularly when you bear in mind what it actually represents. So I'll just go back to Stellarium and just zoom out a bit so you can see where that is. So there's lambda, there's gamma, there's E Valorium where we started. That's the little loop that we were doing to see the main part of the remnant, and the Pencil Nebula is here. All right, so I hope you enjoy that wonderful object. Like I said, wait until you get a nice dark sky, put an O3 filter in, and see how you go. Thanks again, everyone, for watching. I hope you enjoyed the show and found it interesting. Try and get out and look at some of those wonderful objects in Vila if you can, and of course the many other objects on display in the sky. Don't forget the solar eclipse on the 20th, and take a look at that if you can. And for those of you who are travelling to actually see the eclipse properly in Exmouth, Western Australia, I wish you safe travels and, of course, fine weather. So until the next show, clear skies and bye for now.